going to be talking about order of operations. Has anyone heard of PEMDAS before? Raise your hand if you've heard of it before. Awesome. Okay. So these three example problems are just going to kind of segue into it. So let me go ahead and write it up here for us. So we have our first problem is 8 times 4. Our second problem is 19 minus 6 plus 4. And our third problem, we end up having 6 plus 2 times 6. Alright, what do we get for our first problem? What's our answer? Yes, 32. And then number 2, what do we get for our answer for number 2?
7.
I'm sorry, I didn't hear. 17, 9, 17. Let's take a look at it. What's 19 minus 6? 13 plus 4? 17. Good. So these two combined together gives us 13 plus 4, and that gives us 17. Okay. How about our last one? What do we get for number 3? 12. Good. So what we end up having to do with number 3 is we have to first multiply these together, and then we can add our 6 plus 6, which is 12. And the reason why we must do that is because of order operations, which is what we're talking about today. So order of operations is where we get that acronym PEMDAS, an acronym meaning that each letter represents a word. And operations, does anyone know what operations are, or what an example of an operation is? Say what you said again, Cordell. Steps to doing something? Yep. That's a good description of it. Anybody have an example of what an operation is? We do it all the time. I'll give you a hint. Yeah, it's what we do to numbers. So operations are things that we do to numbers. So we have addition, subtraction, multiplication, division. Those are the most common ones. But as you've seen since last class, we also have square root, cube root, we have absolute value. Those are all operations as well. Those are things we do to numbers to combine them together. All right. So the first letter we have in PEMDAS is parentheses. All right, and you'll see that written as curly brace, not curly brace, parentheses like that, or you might even see the square brackets. And we use the square brackets when we have more than one set of parentheses. Instead of using, you could just use a larger parentheses, but oftentimes we'll see square brackets. But you may hear us refer to PEMDAS as GEMDAS as well, because instead of just thinking of parentheses, it's really anything that groups numbers together. So think of it also as grouping, anything that groups numbers together. Can anyone think of another operation that groups numbers together other than just parentheses? Julia? When we multiply? Well, multiplying, that if we had more than one thing we're multiplying together, that would be grouping. But multiplication by itself, just the dot, isn't for parentheses, it creates for multiplication division. So that's a good idea, but if we're multiplying more than one thing together, we would have the parentheses around it. Any other ideas?
Yesterday, or what did we do last class that I said worked as a grouping symbol? Does anyone remember? What did we do last class? Like everything we did last class. There's 2 things we did last class. Anyone have their notes to look at?
You can look at your notes. Thank you, Gabby and Christelle, for being so proactive and actually looking at your notes. There are 2 symbols we used.
What were the things that were the 2 bars?
Good. Absolute value. As you see in problem 5, we have more than one number combined together within that absolute value. So that groups things together. What's one more thing that groups things together? What other symbol do we see that has more than one number within it? Jordy, do you want to help us out? Within these problems, which ones, where do you see another symbol that has more than one number in it? I see you pointing, Julia. 5, yep, we have the absolute value here. We see we have the parentheses here. We see we have the parentheses here. Anywhere else? Yes, 6 does also have parentheses. There's something else that combines numbers together, Gabby. Yes, number 2, the square root here. So a radical also can combine more than one number together. You can have more than one number underneath a radical. Very good. And then also, sometimes when you see that fraction bar, such as number 4, we have to simplify the numerator, and we have to separately simplify the denominator before we can actually do that. So you can kind of think of the fraction bars also need to group together the top and group together the bottom. Alright, so that's grouping. We want to always do that first. Again, this is order of operations, so it tells us which operation to do first. Okay. After we've taken care of any grouping, then we need to next do exponents, and that's our letter E. So exponents are next. And sometimes you'll see exponents using those parentheses, sometimes not. Sometimes it's just a number squared or cubed. Alright, so for example, numbers 3 and number 6 both have exponents there. So that would be the next step, is to evaluate the exponents. Alright, and then remember, evaluate, these are math terms here. So evaluate means to find the actual value of what it is. What is it equal to? What is it equivalent to? Anybody remember what the N and D stand for? Very good, multiply and divide. So we have multiplication and division next. And these are of equal importance. So that means that after parentheses, grouping, and exponents, multiplication, division, we just go from left to right. Whatever comes first from left to right. And then our last one is A and S. Who remembers what A and S stand for? Good. Addition and subtraction. Very good. And again, these are also of equal importance, which means we again go left to right. So like we did with number 2 over here, we first subtracted the 19 and the 6, or 6 from 19, and then we added that number to 4. Okay, so let's go ahead and do a few of these. I'm going to pick a few and then have you work together on your own for a few of them. So I'll start off with number 1. So again, we have PEMDAS. So with each of these, we need to be looking for these different operations. Number 1, do we see parentheses? Yes, I want to hear everyone say yes. Yay, we're all still awake. Okay, so inside our parentheses, we have to simplify this first. So what do we have instead of 2 plus 4? Very good, 6. Since we have evaluated, we no longer need those parentheses, because the parentheses are there to separate it from the rest. Well, now it's one number, so we don't need to separate it. Alright, and then 6 divided by 6? Very good, 1. 1 and done. Questions on number 1? Okay. Let's do number 2 with the radical in there. Do we see any parentheses? But do we see grouping? Remember, grouping and parentheses. Yes. What symbol represents grouping? Very good term. Very good. Radical. Very good. All right. So we need to simplify that first. Anybody know what 9 times 16 is? Go and use your calculator if you've got it. Very good. 144. Who said that? You got that. 4 down. Very good. Alright, now we're going to try to not rely on our calculator so much because if you have to type in, like if you had to type in 8 times 4, that's going to take a lot longer than to just know that that's 32. So in this class, we're going to be practicing knowing our multiplication facts and our addition and subtraction. Just get your brain power going more. That's not to say you can't use your calculator. Always use your calculator check, but we won't be relying upon it for our every need because one day calculators are going to revolt and take over the world and you won't be able to trust them. So we need to be able to know our math without them. Alright, so does anybody know the square root of 144? Don't use your calculator if you don't know. Very good, 12. Is that Cordell again? Well done. Okay, so any exponents? No. So we've taken care of that. Multiplication or division, what do we see? Division. And Julia, what part is being divided? What do we have? What's the division part for this problem here? Good, 8 divided by 12. So you might need to do this in your calculator because that ends up being a fraction. And what do we get when we put that into your calculator? When you have it in decimal, go ahead and go back to math, the math button, and then do fraction. I think I heard it. Very good, 2/3. Alright, so our answer is 2 2/3, which in your calculator as a decimal might be 2.6 repeating. If you were to convert this into an improper fraction, you would have had 8/3. It's the same thing as 8/3. Okay, so any of those would be acceptable. Okay, questions on number 2? Okay, let's take a look at number 5. Number 5, we have now absolute value, and we have that fraction bar. Alright, so again, when we have that fraction bar, we need to simplify the top and simplify the bottom. The bottom's already pretty simplified, right? It's just 2 down there. Nothing more we can do with that. But we do need to simplify the top. So, with number 5, we have 12 plus the absolute value of 3 minus 9. Mitchell, what's going to be the first thing I do to that numerator?
What number? 2?
Number 5.
Number 5?
Mm-hmm. Do we have a grouping or a parentheses up top?
Yeah, 3 minus 9.
Very good, or 3 minus 9, the absolute value there. And what does that give us, Mitchell?
-6.
Very good. And make sure you do write in that it's still the absolute value of -6. We cannot remove the absolute value bars because we haven't evaluated it yet. But as Mitchell said, what is the absolute value of 6, Mitchell?
6.
Very good. So then we have 12 plus 6 divided by 2. And Sydney, what's 12 plus 6? What's 12 plus 6?
18.
Very good. So 18 divided by 2. Judy, what does that give us for our answer? Judy, what does that give us? Very good. So we have 9 for our answer here. So again, just taking a piece at a time. Sometimes you're able to do more than one step at once, and that's fine if you're able to do that. But if you're getting confused or concerned, just take it one piece at a time. It's okay to write more steps. And as Ms. Charlotte has kept emphasizing, you must show your work, especially on homework, quizzes, and tests. We love to give partial credit. If you're understanding part of it, we'd like to reward you with points for understanding that portion of it. Or if you make a simple, silly mistake, we like to be able to give you points for knowing how to do the rest of it, but just having that little mistake. So please show your work so we can give you partial credit.
If you only do it in your calculator and you don't do it by showing work, and you put in one little thing wrong in the calculator, you're going to get the wrong answer, and you're just going to lose all credit. Because we won't have your work to see that you did most of it.
And we're not going to sit there and guess what you
Yeah.
did all day
We're not
long.
going to play mind reading.
We don't have time for that. Alright, any questions on what we have done so far? Okay, let's take a look at number,
6.
which one do you want, 8 or 9? I heard 6, 7, 8,
I
and
don't
9.
know.
6.
There's a code that I know the code, and I know the questions isn't all of them. So Oh, the ones at the bottom.
So any of the bottom ones you're good with? Which one do you want? Solomon?
6.
You want 6? How about we do 6 and 8?
I heard 11 and 9.
6 is fine.
6, 8, and 9?
6.
Jocelyn said no. Alright, so we'll start with 6. Okay, so now we have 2 groupings, right? We see we have the square brackets and we have the parentheses. When we have more than one grouping, we just work from the inside out. Because if you look at it, we need to simplify this, right? Well, inside of here, we have to first simplify this guy. So you're working from the inside out. So starting off, again, let me rewrite PEMDAS up here so we can know our order. Alright, so our inside grouping, we have 7 minus 4. And what does that simplify down to? 7 minus 4. Very good, 3. So instead of 7 minus 4, we have 3 squared. So now within here, we have to simplify again. So next up would be exponents. So we have 9 plus 3 plus 15. And Jordy, what does 9 plus 3 give us? Oh, it's 9 plus 3. It's just 9 plus 3. 9s are always the trickiest for us. What would 10 plus 3 be? 13. But we need 1 less, right? So it'd be 12. Very good. So 12 plus 15, which gives us what, guys?
27.
Very good, 27. Turn to that. Questions on that one? Okay. I'm going to practice some more names. I'm going to call on Evan, then Cynthia, then Jenny, and Luis. Okay. Evan, what do you think is the first thing, or what's one thing that we can do with number 8? Where do you want to do? Top or bottom?
Top.
Top. Alright. So remember with our fraction bar, we have to simplify both the top and the bottom. Alright, so what do we have happens within our parentheses, Evan?
Oh, 5 minus 3, 2.
Very good. So 5 minus 3 is 2. So 2. Okay, next. Cynthia. What is something else you can do? Let me ask you this. Do you see any other parentheses or grouping within our problem there? On the bottom. Very good. Okay, so let's take care of those parentheses. So we have to work from the inside out again. So we have to deal with the 1 plus 6. What do we get with 1 plus 6?
7.
Very good. So we have 7. Okay, Jenny, what do you want to do next? Very good. So we're going to go and simplify the top some more. So 2 squared. And Jenny, what does 2 squared give us? Very good. So on top we have 4 times 4. Alright, Luis, you're up next. Do you see parentheses or brackets down here in the denominator? Alright, so we got 7 minus 8. What is 7 minus 8? Very good, negative 1. Be careful with your negatives. We deal with negatives a lot in this class. So if you see your larger number comes after the subtraction sign, it means your answer will be negative. So we have negative 1. 5 plus negative 1. What is that the same thing as? Right, just 5 minus 1. So if you don't like those double signs. Okay, now we're almost done. Let's go with Carla. Is that your name? Okay, Carla, what can we do next?
4 times
Good, 4 times 4, which gives us what? 16, very good. And in the denominator, we have 5 minus 1, which gives us 4. And everybody, what's 16 divided by 4?
4.
4, very good. That's our final answer. Questions on that? Okay, so for this next problem, oh, sorry, go ahead, Krista.
What if you do the like you do the top all of it and you do the bottom, and now you do
that is fine. That is perfectly fine. You can simplify the top by itself. So you could say, okay, well, 4 times 5 minus 3 squared. So 5 minus 3 squared is 2. 2 squared is 4. 4 times 4 is 16. That's perfectly fine. And then do the bottom row by itself. You'll still end up with 16 over 4.
But I do ask you guys that, like, Miss Marta, she just said it in her head. You not do that in her head.
Yeah.
Write
Show
it
us
all
the-
out. Everything she said, write out. I know it takes time, but that's the only way. We can't, like, open your head, look at your brain, and see what you're saying, okay? You can't tell it to us as you do this test. So you guys show your picture. Only way of telling us how you came up with the answer.
And sometimes there are some pieces that you might do 2 steps at once. Like Christelle, maybe here you say, oh, 1 plus 6, that's 7, minus 8, which is -1. So you might skip this step. That's fine, but don't go from this to this. We want to see some work so we can know what you're doing. Good question. Other questions before I move on? Okay.
I wouldn't skip a step unless you're super duper confident in it.
And even then, I still don't want to skip
Yes.
steps.
What? No, you will not lose credit if you don't show your work. But if you get it wrong, you'll get no credit whatsoever.
Correct.
So if you do it all in your head, and you happen to get it right, then you're fine. But I'm telling you, even the smartest, I had a kid in my class last year who was really smart, and he actually had already taken algebra, but he didn't show his work, and he got a lot of problems wrong because he just did it all in his head. And you can't be perfect. None of us are perfect. We don't have calculator mountains.
I guarantee you, I will make mistakes all the time. I made about 5 mistakes in one geometry class last time. So, and let us know if we do make mistakes. Please don't let us continue with making the wrong mistakes. And also, you'll see too, there is a lot of arithmetic you have to do, so it's easy to lose it in your head too, especially when we get the negatives. Okay, so for number 9, we're gonna have Julia, and she's gonna put away her phone. And then Jocelyn, and then Luis, and then Mitchell, and then we'll see how far they get us. Okay, so number 9, Julia, what's the first thing we can do? Right, do the parentheses. But notice inside my parentheses, there's even more that's happening. So we have to first do the absolute value within the parentheses. So we have parentheses. And Julia, what's the 6 minus 8 give us? Yeah, -2. Very good. And we put plus 3 squared minus 6 plus 4. Okay, I think I said Jocelyn. Jocelyn, what can we do next? You're not sure? So let's take a look again at our PEMDAS. So we see parentheses, right? But then again, we still have to do inside of it first absolute value. That's one of my groupings. So what's the absolute value of -2? Very good, 2. All right, so we have 2 plus 3 now. Okay, where do I go next? Luis, you're up. What do you think we'll do next? Okay, that's fine. Let's start back up at the top. Do we still see parentheses? Yep, so we have to start off with parentheses. If you see those, you've got to take care of it. So let's simplify inside our parentheses. What's the 2 plus 3 give us?
5.
Very good. So we finally have 5 squared minus 6 plus 4. And then Mitchell, what's next? Very good, the exponent. We finally took care of all of our parentheses and grouping. So now we can move on to the exponent. And what does 5 squared give us, Mitchell? Very good. 25 minus 6 plus 4. We have no multiplication, no division. We're finally down to just addition and subtraction. So we go left to right. 25 minus 6. Very good, 19. And 19 plus 4, which gives us?
23.
Very good, 23. I think these 9s are the most confusing part of addition and subtraction. Very good. Okay, any questions on that? Awesome. I want to see just thumbs in front of you, thumbs up, thumbs middle, thumbs down, how you feel about this topic and all these orders of operations. Okay, I'm going to give you a chance to try some on your own, and time for me to come around and help out some of you that are struggling still. So I want you to now work on 3, 4, and 7, the problems we have not done yet. And then we'll come back together and go over the answers. If you are struggling, if you give me a thumbs down or even a shaky, I want you to raise your hand so I can come help you as we work through this together. Do you have a question, Gabby? Are you, oh, sorry, Jenny. You have a question? Okay, I'll come to you. Right, so again, you should be working on 3, 4, and 7. I want to see everyone working on it. Okay, so let's take a look at 3, and then we'll go back over 6. So I'm going to do 7. So 3, we have to first do 10 minus 7, which gives us 3. And 3 squared is 9, so that's what we have here for majority. So we have, instead of this whole chunk, we know this is equivalent to 9. So we have 5 times 9, and 5 times 9 is 45, which is your answer there. And then number 4, we have a lot going on here. We have our numerator with a lot happening and our denominator with a lot happening. So in our numerator, we have 48 divided by 12, which reduces down to 4, and that's this piece here. And then in our denominator, we have 2 cubed, which that is 8, plus 4 minus 3. And then that's this down here. And then 8 plus 4 is 12. Minus 3, and 12 minus 3 is 9, so our final answer is 4 and 6. Any questions on those two, 3 or 4? Okay, and then Christelle, you ready for a 7? Taking a look at number 7 here. So Christelle went ahead and simplified the numerator. So we have 7 minus 2 minus the quantity 2 minus 6 squared. 2 minus 6 is negative 4. Negative 4 squared is 16. And 7 minus 16 is negative 9. So that gives us our numerator here. And then 3 minus 4 gives us negative 1. Negative 9 divided by negative 1 is equal to 9. Very good. That's our final answer. I do ask that when we have a fraction like this, to go ahead and carry through that over negative 1 each time. We don't want to lose that fraction the entire time. Keep it as a fraction. Okay. Questions on that front side? Okay. Order of operations, this usage of PEMDAS is extremely important for the rest of your math career. All later math classes use this. It's one of the building blocks for algebra, geometry, really just any math class. So it's really important that you do make sure you have a good understanding of this, and that if you're struggling, to let Ms. Charlotte or myself know, because this is not going away. It's pretty much in every single thing we do from here on out.
This is where we're really starting to pick up the pace. So again, if you're struggling, do not wait until the test. Do not let yourself down. Come in and do little fixes at a time. We're doing long sessions trying to understand the whole chunk of information.
Yep. Okay. So evaluate with order of operations, this is pretty straightforward actually. So evaluating, that's a word that we've been using, another math word. That means we want to know what the actual value is. So our steps to evaluating expressions. Remember, an expression is where we have numbers and letters sometimes, variables and numbers, combined together with operations. So x plus 4, that's my expression there. So evaluating means finding what the actual value of x plus 4 is. Now when we look at just x plus 4 by itself, if I didn't have this piece here, I wouldn't know what that value is, because x is some variable, it's some number. We don't know what that number is. So if it just said evaluate x plus 4, we'd have no idea what that value is. So we're going to have to be given more information. We need to be told what x is. Right. So the first step, write the variable expression with parentheses instead of the variable. Alright, so this is just to help us with knowing where we're going to substitute in that value. So for example, number 1, evaluate x plus 4 when x is 12. Well, instead of having x, we're going to substitute this guy in. So what we do is put parentheses instead of x plus 4. Now with some of these more basic problems like 1 and 2, the parentheses isn't super necessary, but when we get into larger problems, then such as number 3, where you end up multiplying, then those parentheses are important. So yes, it's not really needed for number 1, but it's good to get the habit for when we do it. Okay. The next step, substitute the given value into the parentheses. So the given value is going to be whatever number they tell you to substitute in. So here, again, like I said, our given value is x equal to 12. We're taking that and we're substituting it in for x. So instead of x, I have 12. Then we simplify. And with this, we use order of operations. And that is our PEMDAS. Or you can think of it as PEMDAS. Okay. We use order of operations anytime we are dealing with expressions. That is extremely important. We use order of operations for any time we're dealing with expressions. So we use PEMDAS for expressions. And usually we'll see the word simplify with it, but not always. Right, so then we look and we use order of operations. Well, there's only one operation, addition. So there's not much of an order to choose from. Just do 12 plus 4, which is 16. So what we're saying is, this expression x plus 4 is equal to 16 when x is 4. Questions on that? Okay. So let's take a look at number 4 then. So number 4, it still says evaluate. This is still an expression here. This whole thing is an expression. And it says evaluate when x is equal to 4, y is equal to negative 2, and z is equal to 6. So they give us values for each of our variables. And we're going to take those values, and I'm going to substitute in 4 for x. I'm going to substitute in negative 2 for y. I'm going to substitute in 6 for z. Again, we're just substituting for each of those variables. So for number 4, we have negative 3 instead of x, parentheses, x is 4, plus y minus 2. But again, instead of y, we now have negative 2 minus 2 squared. And then negative 2, and instead of z, we have 6. Alright, then we use order of operations to simplify. So negative 3 times 4, that's going to be our negative 12. So our plus. We have to simplify inside of our parentheses, right? PEMDAS, P. Negative 2 minus 2 is going to be negative 4 squared. And then negative 2 times 6 would be negative 12. Alright, still need to take care of our exponent. So we have negative 12 plus negative 4 squared. Be careful with this in your calculator. When you put it in your calculator, make sure you use parentheses. And that should give you 16. So plus 16 over negative 12. Negative 12 plus 16, what does that give you? We get 4. Divided by negative 12. And we can simplify that. Remember, reducing fractions, we can reduce both the numerator and the denominator by 4. So 4 divided by 4 is 1. Negative 12 divided by 4 is negative 3. So my final answer is negative 1/3. Answer today. Questions on this? I want you to go ahead and try number 3. Here. Evaluate 2x minus the quantity 5 minus 3y, quantity cubed, when x is negative 3/2 and y is 2. I want you to try that one. And if you get that done before we go over it, go ahead and try these problems down here. So I want you to try those, and we'll come back together and go over it. at what we have here. What do we get for number 2? 15 minus, instead of A, we have 9. Equals 6. Very good. All right, and then number 3 had to do with fractions here. So we have 2 times x, but instead of x, we have negative 3 halves. This is a spot where those parentheses are really important to remind you that it's multiplication here. And then minus 5, oops, 2 times x minus parentheses. That's my parentheses here. 5 minus 3, and instead of y, we have times 2. You could have used parentheses here as well. Here. All right. So then 2 times negative 3 halves. Remember with fractions, we just multiply straight across. So 2 times negative 3 is negative 6. 1 times 2 is 2. Alright. And then let's simplify the inside of my parentheses. So I have 5 minus 3 times 2. I have to multiply first. So 5 minus 6 cubed. Alright. And then what's negative 6 divided by 2? Get negative 3. And 5 minus 6 gives us negative 1. And Luis, I think we had squared there. Alright, so cubed. What's negative 1 cubed?
1.
Close. Negative 1, yes. So did you say negative?
I was like 1.
Sorry, I missed it. So 3 minus, and this product here, this is negative 1. So 3 minus a negative 1. And what's minus a negative the same thing as? Plus a positive. Minus negative plus positive.
When we square numbers, we can only get positives, but I have a negative there. Why? Am I squaring that number? Am I squaring or cubing negative 1? Cubing. So that means that I can have negatives and cubing.
If you're ever worried about that, use your calculator to help double check.
Please do use your calculator to check.
Alright, and then negative 3 plus 1? That's negative 2. That's right there. Questions on that? And then for time's sake, I'm going to go ahead and just quickly go through 5, 6, and 7. So please do stop me if you have a question on what I'm doing. Alright, so here A is 64, so that's what I'm going to substitute in for A. And B is 4, so that gets substituted for B. So I have off to the side negative 1 times the cube root of 64 plus, instead of B squared, 4 squared. Negative 1 times cube root of 64. Everybody figure that one out? 4. The cube root of 64 is 4. And if you've forgotten where that is in your calculator, it's under math. You have to hit that math button and then it's option 4. Okay, and then plus 4 squared, which is 16. So negative 1 times 4 is negative 4 plus 16, which gives us positive 12. Questions on that one? Okay. Number 6, a little bit more work here because we have not just x, but also x squared. And we have fractions. So again, this 2 sevenths is going to be substituted in for x in both places. So instead of x squared, I have 2 sevenths squared. And instead of 7x, I have 7 times 2 sevenths minus 2. For a fraction squared, you actually just square the numerator. So I have 2 squared, which is 4. And you square the denominator. So 7 squared, which is 49. And then again, for fractions, we just multiply straight across. So 7 times 2 is 14. 1 times 7 is 7. And then we have minus 2 on the end. 4 over 49, can't really reduce that at all. There's no common factors. So 4 49ths. What's 14 divided by 7? 2. So plus plus 2 minus 2. Ah, what does positive 2 and negative 2 do to each other? Yeah, they cancel each other out. So if I have $2 and then you take $2 away from me, I have $0. So those get canceled out. And I have then just 4/49 as my answer, which is letter A. Anybody get that one? Raise your hand if you got that. Good. Okay, then finally number 7. I think this one was a little bit easier than number 6. Alright, so we have n is equal to negative 11, so that gets substituted in. So negative 3 times the outside of negative 11 plus 6. Again, have to deal with my grouping of my absolute value first. So negative 11 plus 6 is negative 5. So I have to do with my absolute value. Absolute value of negative 5 is positive 5. And now I can do my multiplication. Negative 3 times 5 is negative 15, which is B. It's a little bit quicker to make sure we got through. Same concept, same idea. Evaluating, we're substituting in these values for those variables. Again, you do this a lot. Do it in algebra 2 as well. Any questions on those? Alright, see, we're eyeing the clock. We're making it, guys. One last page. So 8, 9, and 10, it's still evaluate. It's just another way of setting it up. Who remembers graphing coordinate points or graphing lines? Graphing anything on your x and y axis? Hopefully more than 30 of you did it. Alright, so this right here, y equals x plus 2, that's actually just a line. If I were to graph this, I would have something that looks like this. Now, the way we actually were to find each of those points on the graph is by substituting in those values for x and finding what y is. And that's all we're doing with evaluating. So they're telling us to evaluate when x is equal to negative 2, when x is negative 1, when x is 0, and when x is 1. So what I'm doing with each of these values is just simply substituting it into my equation up here. So let's take a look at what that one says. Okay. So we have y equals x plus 2. So instead of x, I have negative 2 plus 2. And negative 2 plus 2 is 0. And that's my y value, right? I put in negative 2 plus 2. I get 0 is y. And then I do that for each value. So instead of x plus 2, negative 1 plus 2, which is 1. Instead of x plus 2, I have 0 plus 2, which is 2. And then I have 1 plus 2, which is 3. And again, if I were to graph this, negative 2, 0, negative 1, 1, 0, 2, 1, 3. There's that line that I was telling you about. That's how we achieve it. Any questions on that? Okay. So same idea for 9 and 10 as to what we were just doing. Each of these values gets substituted in for each x value. And the same thing over here. Okay, so let's take a look at the investigate, because this is a really important concept with algebra. It says, is x plus y squared the same thing as x squared plus y squared? Okay, so it's asking. Go away. It says, is x plus y, that quantity squared, is that the same thing as x squared plus y squared? Right, we could do a formal proof, but we're just going to check it with our values. Evaluate each when x is 2 and y is 3. I'm just going to do that real quick at your desk and see what values you get for each side. Alright, what did we get for the left side of our equation? X plus y quantity squared. What did we get for that? 25, very good. So 5 squared, which is 25. Now how about the right side? When we did each individual term squared, what did we get? 13. Are those the same values? No way. They are not the same. So 25 does not equal 13. Therefore, we know that x plus y quantity squared is not the same thing as x squared plus y squared. And we'll actually be dealing with that later this year when we start foiling and distributing. So it's really important. They are not equal. And this equal sign with the line through it means not equal to. Any questions on that? Okay, so numbers 1, 2, and 3, and 4 down here below, they're pretty challenging, tricky problems. It says, can you fill in the operations to make the equations true? Alright, so they tell us that they're equations, so we see these equal signs here. But they don't give us whether it's adding, subtracting, multiplying, dividing, grouped with parentheses. So what I want you to try is just, I'll show you number 1, and I want you to try number 2 while I'm passing out your homework to you. But basically, you want to take the operations and see how you can get these numbers to combine together to give us 25. So for example here, I know 4 times 5 is 20, but I need 25, and if I add 3 to that, I add 2 to it, then I get 25. Because by order of operations, I don't have any parentheses, but I have to do my multiplication division first, right? So I have 3 plus 20 plus 2, which gives me the 25. Alright, so I want you to try number 2 while I'm passing out your homework to you and see if you can figure that one out.
When you finish this problem, you may come back and trade in your calculator. You are in the last 2 rows. Probably you see this mark outside.
Okay, so again, you have your homework in front of you. That's worksheet number 9. That's due next class. And we will have another mini quiz over what we learned. Keep in mind your test is next Tuesday.